Hello dear students, how are you all? Welcome to Diksha Karnataka YouTube channel. I hope all of you are doing very good. Okay, as you know, we have finished our entire chapter of integration. We have complete all the types of concepts, all the concepts and different type of questions, different type of approaches to solve the integration, definite and indefinite, applied to the different properties of by parts, partial fractions, and different formulas and approaches. Substitution method also we have solved in detail. Okay, concluding with the properties of integrals in the previous sessions that we had for integration. All right, so in today's session, as we promised, okay, I told you I'll come up with a session just specifically for revision. Okay, so we are starting the session number 1 for revision. All right, in this session today we'll solve 10 very important questions. Why important, sir? Because again I've taken variety of questions from different category. We'll be using substitution, okay, we'll be using trigonometric substitution, another kind, and we'll be using some challenging questions as well to solve and clear our concepts. So I hope you are ready to revise it with me. Integration, one of the most important chapter of your PU2 syllabus and your KCET syllabus. So for that reason I've been very patient. I've solved a lot of questions with you, and I'm going to try to solve more questions in the revisions. Okay, so let's start with the session. I hope you are prepared. I hope you have kept what is very important, keep your formula sheet with you. If you have not prepared it by now, make it today. Okay, at least make it on calculus integral part today only. Have the formula sheet ready. If you are ready, if you have it with you, keep it with you. Okay, if you want to take a break, go ahead, take a break, then come back, have some water, start with the session. Once you start with the session, what you have to do, complete the entire video. Okay, complete the entire session, solve all the questions with me. If the questions is getting difficult and tricky, what are you going to do? Pause the video, solve from your side, make your own mistakes, then come back and see the solution. This will help you relate to the problem very easily. Alright, so moving on, first question coming up in the revision series. So today bacha will only talk about questions. Okay, we'll have only questions to deal with. We'll have no concepts here. We'll try to recollect and revise the concepts with the help of questions only. So coming up first is what? Find the integral of x square upon a square plus x square power 3/2. I think we have solved this kind of question in the regular series sessions also, but this is a very good question. What we're going to do? We're going to take x for substitution, right? So let me see how will the substitution look like, bacha. So if you see here, if I take, so if you check, I have given a session on substitution where I talked about what to substitute. If you go and check that, you can see based upon the identity for trigonometry, I can put what? X equals to a tan theta. Please check. X equals to a tan theta, right? What we have to do now? We have to differentiate both sides to get my what? Dx value as well. If I do that, what I'm going to get? Please check. I get dx equals to a, what is it? Sec square theta. Okay, I'm differentiating x with what? Theta only. Okay, take d theta over here, take d theta over there. I get a sec square theta d theta. Am I right? Yes. All right, a sec square theta d theta. If it's now use the substitution over here, what I'm going to get? Please check. I can write it over here only. I'll have this integration as x square will become what? A square tan square theta. This is just for x square. Okay, what about the denominator? Please have a look. For this I'll get what? A square plus, so I'll write a square as it is, plus what is x square, bacha? A square tan square theta again. So a square tan square theta whole power is 3/2. So write it here as 3/2. What's the dx going to replace by? Same thing over here. I can replace dx by the same thing over here. Not enough space, so I'll write it on this side. Please have a look. I can take a square common denominator. So I can write this step as again integration of a square tan square theta. Okay, I'm write this dx value now, a sec square theta d theta. All right, over here what I have, bacha? I can take a square common. This will become a square times of 1 plus tan square theta, okay, to the power 3/2. All right, now if you check here, I can cancel this 2 with not this 2 right now. I can take one more step. I can take this one more step. What is the other step, bacha? Writing 1 plus tan square as sec square theta. Let me do that. A square tan square theta. Okay, again a sec square theta d theta. Moving on, what I have over here? A square sec square theta to the power 3/2. Now if you check here, at this time I can cancel this 2 with both the 2's because whole square I can take and 2 will be neglected. Now see the next step. What I'm going to get, bacha? I'll have this as, please check, a square and a will become a cube, will become a cube. I'll have tan square theta sec square theta d theta upon simply what, sec cube theta. How much is this? Sec cube theta. How come, sir? Please check. So if you write this, okay, a will also be there, a cube is also there, a power 3 a cube, sec power 3 sec cube, a cube and a cube is cancelled, sec square is cancelled with sec square over here. I have one sec left. Please check in the next slide. So what is my integration? Integration of tan square by sec theta d theta. So over here, if you look at this, what do you have? We will become a tan, so integral of tan square theta upon sec theta d theta. Please check, correct? Okay, I have one sec left here. Okay, now moving on. So write this as integral of what? Sec square theta minus 1 upon sec theta d theta. Alright, divide this individually. What are you going to get? You're going to get sec theta minus, how much is that? 1 by sec theta d theta. Have a look, please, have a look. Sec square by sec is what? Sec, and 1 by sec is simply 1 by sec. Integrate this. What are you going to get? This over here, sec theta. Okay, please have a look, 1 second. Sec theta d theta integration minus integration of what? 1 by sec is how much? Cos. So cos theta d theta. What's the answer, bacha? Please check. For sec theta, what I have integration as log of sec theta plus tan theta. The integral of sec theta is log of sec theta plus tan theta. And for minus cos, I'll have what? Cos will be simply sine. So minus sine theta and plus c, the constant of integration will come. This is my answer. So, but if you want the answer in terms of the variable they've given, what's the variable they've given? X. What's the condition over here? X equals to a tan theta. Write it over there. X equals to a tan theta. So what's my tan theta over here, bacha? My tan theta is x by a, x by a. So find the sec and sine from here. Find the sec and sine from here. So what is going to be, what is this basically? Okay. So I can write this as, 1 second, I can use the identity over here. I'll show you for the sec, sine you can find from your side. Okay. So what is going to be sec theta? So sec square theta is nothing but root of 1 plus tan square theta, not sec square, simply sec theta is what? Sec theta is 1 plus tan square theta, because sec square is what? 1 plus tan square. So sec theta is going to be root of 1 plus tan square theta in the root. Okay. Put it here, 1 plus x square by a square. What is we getting? A square plus x square by a square. This is the value of my sec theta. Same we find sine. Sine also you find it out and put it here. Put the values of sine, tan and sec. This is your final answer. Comment the final answer for question number 1. For question number 1. Alright, let me know what is you're getting. From here only you can get, right? I've given for sec theta, find for sine and put it in the final answer, which is log of sec x plus tan x minus sine theta. Please have a look. I hope this is visible. Okay. Over here also. Now for this question, question number 2, if you check here, I have what? I can write this x power 5 as x cube and x square. Good thing is that I also have x power 3 here. Okay. So we have to prove this integral is equals to what? There is a function given in that form, 1 by 48 e power minus 4x cube and fx, and we have to find the value of fx. We have to find the value of fx. Okay. Where c is the constant of integration, no problem there. Okay. So and we know that x cube differentiation will come in terms of x square only. So let's take the substitution right now. We take a substitution of x cube as t. I get this as 3x square dx equals to simply dt. So I get what? X square dx is equals to dt by 3. Am I right? dt by 3. Now put it here. Use the substitution. So write this integration. So I can write this integration like this. I equals to what, bacha? I equals to integral of, tell me here, x cube I can write first. So x cube I'll write it over here. Now e power minus 4t I will write, because t is my x cube. Okay. Dx I can write it as, so I'll write first this like this, x square dx. Now have a look. I can transform this as t e power minus 4t, and this is simply dt by 3. Okay. I can take this 3 outside and write over here 1 by 3 t e power minus 4t dt. I'm going to use what? My eyelet to solve this by parts. Can you check? This is by parts, no? Exponential and algebraic function. So algebraic has preference. So this is 1, this is 2. Okay, what is the order for by parts? 1 by 3 is the constant, keep it outside. Keep the first function as it is. Integrate, integrate the second one. E power ax difference, what is the integration of e power ax? E power ax only divided by a, okay? Minus sign, integrate with the differentiation of first one, so this is, and the second one integration, same thing, e power minus 4t upon minus 4, okay? Constant will come, so c, integration of c, okay, will be there. Now one more thing, I have to integrate this part again. Let's have a look. So I have so far 1 by 3, integration of what is this, bacha? Simply what? T e power minus 4t, there's a minus sign there, so I write it as minus t e power minus 4t upon 4, please have a look, upon 4, okay, and this will become what? Simply, I have to integrate again, so minus sign is there, it will become what? Simply e power minus 4t, minus 4 was already there, I have to write another minus 4, please have a look, how come so? Integrate e power minus 4t, again you will get what? E power minus 4t divided by the a value. What is a value? Minus 4. What I'm going to get over here? Please check. I get 1 by 3 minus t e power minus 4t upon 4. And how much is the picture? Minus plus and then another minus. So minus e power minus 4t upon how much? 16 is there and plus c. Please take 16 out. Please take 16 out. I get what? 1 by 3. Okay. 1 by 3. If you want, I can take 4 out. If it's difficult to understand, no, 16 directly, take 1 by 4 out, okay? But I don't think this will be difficult to understand taking 16 out, right? If I take 16 out, I have to multiply 4 in the numerator, right? Because there's only one 4. I'm taking 16 out. I have to multiply 4 over there. So I'm taking what? 3 times of 16. I've taken 16 common and e power minus 4t also common. What I get? I get as, what is this? Please check. This is going to be minus t minus 1. Okay, minus t by, I think this will be minus 4t, right? Minus 4t and minus 1 plus c. Why minus 4t? Cross multiply. 16 with 4 will be what? Again, 4 in the denominator. Same thing is there, no problem. Now please have a look. 1 by 48 e power minus 4x cube is there. 1 by 48, 16 to 3 is 48, e power minus 4x cube because t is nothing but x cube only. So same thing is there. Means I have matched this. I have matched this part. Whatever is remaining is my fx value. What's remaining, bacha? What's remaining? Minus 4t minus 1 is my fx, but fx we have to write in terms of x cube, so minus 4x cube minus 1 equals to f of x. This is my answer or not? Please have a look. Option number B is the correct answer. I hope this is visible. Yes, okay. Moving on to question number 3. What are we going to do here? So please take, so again we have to use some substitution over here. If you remember this form, I have to use what? X equals to a sec square. No, not sec, sir. A sine square I can use, bacha. Not sec. I can use what? Sine square. Why? Because, sir, because 1 minus is there. So sine square will work better. So a sine square theta. Now please check after substitution what it's going to be. It will become what? My integration I will become what? Integration of the root will be there. A minus x is there. A minus x. It means what? I'll replace x by a minus a sec square theta divided by not sec, a sine square theta, sorry, a sine square theta and divided by a sine square theta. Alright, a sine square theta. Now please check. Integration of, I can take a common in the numerator. I get what? 1 minus sine square theta, okay, divided by a sine square theta d theta. Am I right? Okay. Have a look. I can cancel a and a. I get what? I get this as cos square theta by sin square theta, okay, d theta. Yes, all right. Now have a look. So, Asha, one more thing. I have to write the differentiation of this also, right? I am writing this directly d theta, but how, sir? Because there is a dx over here. I have missed that part. So let me just do it over here on this side. So my x is equals to what? A sin square theta, right? What is going to be? Dx equals to, what is going to be, Bacha? Tell me. It's going to be a 2 sin theta. I'm differentiating, right? So sin square will become 2 sin theta, and I have to differentiate sin theta also. So it will be cos theta. There's a d theta over here. I can write it over this side. So this will be a, so 2a sin theta cos theta. So I have to write here what? So please check. I can write this as d theta. So I'll replace d theta later. Okay, I don't have enough space over here, but I'll replace it later. Okay, in the next slide. So if you check here, what I'm gonna get? I'll get cos by sine, right? I'll get cos by sine. So I can write this as, in over here, I equals to integration of cos theta by sine theta, and in place of, okay, one more thing, this is not d theta, this is dx bacha. Okay, this is dx, because I've not done the replacement. It's incorrect way to write it. I'm just writing it like this to save space. You cannot write dx over here because variable is theta now, but I'm writing like this just to make, you know, have some space over here. Understand this dx value is this condition. How we got this? Differentiating the substitution. I got dx as 2a sin theta cos theta. I'm going to write it over here now if you check. So 2a sin theta and cos theta with the d theta. Please check, sine and sine goes out. 2a is a constant, take 2a outside. Okay, do one thing, don't take 2a outside, just take a outside. You'll see how. Because I'm getting cos square, no? So make me form a formula for me. A 2 cos into cos is how much? I've taken this a outside. Cos into cos is how much? Cos square theta d theta. Is it right? How much is this, bacha? I can write 2 cos square theta as, sir, 1 plus cos 2 theta, sir. Okay. Formula of cos 2 theta, right? Okay. Now please take this as it is. This will be simply theta, and what will this be? Plus sin theta, sin 2 theta by 2. Okay. How much is that? So a theta plus 1 by 2. Okay, I can write the values over here. What's my theta value? Please check. I can get this theta value as, check the assumption over here. I got x equals to a sin square theta, no? So I can write this as x by a equals to sin square theta or not? Okay, yes or no? I can write this as root of x by a equals to sin theta or not? Yes. So I can write this theta as sin inverse of x by a or not. Okay. Now please have a look. Please have a look. So I replace it over here. I get it as a times of, how much is this, bacha? This is going to be, first theta is there, so I can write it as just sin inverse of x by a, sin inverse of root of x by a. And what about this one? Plus sin square, sin 2 theta is there. Okay, so sin 2 theta can be written as what? It has to be written as 2 sin theta cos theta upon 2. Please have a look, 2 and 2 goes out. Okay, now sin theta I have. Sin theta I have. What is cos theta going to be? Cos theta is going to be 1 minus sin square theta. How much is that? 1 minus, acha, this thing is in the root. Cos theta will be 1 minus sin square theta in the root. So 1 minus x by a. How much is that? Simply a minus x by a. A minus x by a. So if you check here, any value like this, okay, I think the d part, check here, a sin inverse of x by a is there. A sin inverse of x by a is there. Okay, all right, yes. So I think this will work. So if you substitute this value, this will come as a sin inverse of x by a. You have to multiply a again over here for the second term. So a will come, but for sin theta, what are you going to get? Root of x by a. Root of x by a. And for cos, I'll get what? A minus x. A minus x by a. So root a and root a in the denominator will cancel the a in the numerator. I'll get what? Sin inverse of x times of a minus x. Okay, and the plus c will be there for the constant of integration. My final answer is d, bacha. I hope this is visible. Please have a look. Yes. Yes. Okay. If you want, I can just encircle this as my final answer. This is my final answer. This is my integration. Just this, the last step is left. I can just cancel this a with this root a and root a. How come, sir? Because root a into root a will become what? A in the denominator. We will cancel with this a in the numerator. This a was the constant outside. Yes. Moving on. Question number 4. Question number 4. Now over here, I can use this substitution as what, sir? Have a look. X square is there, no? Then I have to write what? X square minus 1. I can use this x as simply what? Sec. Okay, I have to write a again. So a sec theta. A sec theta. Yes or no? A sec theta. Okay. What's the differentiation, bacha? Have a look over here only. Why to keep it for later? So dx will be what? A sec theta d theta. Not d theta. Tan theta. A sec theta tan theta d theta. Am I right? Okay. Now replace these values. Okay. So I'm gonna get what? Integration will be equal to root of what? X square is what? A square sec square theta minus a square upon what I have, just simply a sec theta. Okay, because x is a sec theta. What I'm going to do, multiply with dx. Dx is how much? Dx is a sec theta tan theta d theta. Am I right? Okay. Now do one thing, take a square common, and if you take it out, what are you going to get? Please check. It will become simply a. I have this inside, sec square minus a. Sec square minus 1 I'll have sec square theta minus 1 upon a sec theta, and what I have here, I have simply as a sec theta tan theta d theta. Am I right? Sec and sec goes out, this a and a cancel, I have this a left, so I write it as a, and how much is sec square minus 1? 1 plus tan square, 1 plus tan square theta is sec square theta. It means sec square minus 1 is simply tan square theta in the root, so simply tan theta, simply tan theta. What is left now? Over here also tan theta. Okay, d theta. What is this, bacha? A tan theta d theta. So have a look. I can write this as integration of a is the constant outside. I can write this as tan square theta d theta. Tan square theta d theta. What is this? Please check. So my final answer over here has become, anything else is left, a tan square theta d theta. So have a look. Yes. Anything I'm missing? A tan square theta d theta. Okay. So I can move to this. So I can write this as I equals to a. Okay, a can be written outside. I've done nothing but written the same thing over there. Okay. Do one thing. Just write this value. Integration of what? Sec square theta minus 1 d theta. What is going to be, bacha, tell me? This will become simply, sir, integration of sec square is how much? Sir, tan theta, and how much is this? Minus theta plus c. Minus theta plus c. But we want value of theta from here, right? So I can find it from here, no problem. So I am looking for what? A tan theta minus theta. What did I assume? I assume x to be a sec theta. Have a look. X to be a sec theta. So what is my theta value from here? X by a equals to sec theta is there, right? So what is my tan theta? Tan theta is going to be simply, what is it? Sec square theta minus 1. How much is that? X square minus a square minus 1. How much is that? X square minus a square upon a square in the root. Okay. And what is this value of theta? Theta is going to be simply what? Theta is going to be sec inverse of x by a. This is my answer. I got my tan theta value and sec theta value, put it there and get the final answer. Okay. I hope this is visible. Have a look. Yes, moving on. Chali. Let's move on to the next question. What is this? This problem says, okay, fx dx integration is given as fx by 2. So first of all, whenever I can have this integration same as this one, will be what? Exponential function. But if it is divided by 2 means what? I should have a and a here. It means what? I should have e power 2x as fx. Okay, e power 2x as fx. What is this? Only one option is there. E power 2x as fx. Okay, not c, right? C will be after the integration. No, why will I write c over there? Okay, so e power 2x is my answer. So it's D. Very simple question. Okay, very simple. Moving on. Okay, integration, they have given two parts here. I1 equals to this integration, I2 equals to this integration. Then find the ratio of I1 and I2. Okay, so find the ratio of I1 and I2. All right, so let's see. I'll take the I2 first. Okay, because I can resolve this somehow in I1, because power is more over here. If you see here, 101 is there. I can resolve this from here. So let me try to use the I2 first. So integration 2 if I'm using, This is definite integral. So 0 to 1, the limits will be like this. I can write this as power 101 is there, no? So I'll write this, I split this power. X power 50 power 1 and 1 minus x power 50 power 100. Yes or no? Why, sir? Because power 101 is there. I can write the same base, split like this. Now multiply this thing with 1 once and multiply this whole thing with x. So I get what? Integration from 0 to 1. I'm multiplying with this just 1. I get what? Please check. I get 1 minus x power 50 to the power 100. Will remain same, no? Please check, because 1 is there. Now I can write dx here, and then this part integration. I'm separating the integration for this minus sign. I'm separating the integration for this minus sign. I get minus. I get what? X power 50. 1 minus x power 50 to the power 100 dx. Limit will remain same, 0 to 1. Please cross check. This is nothing but, this part is nothing but my I1. Have a look. 0 to 1, 1 minus x power 50, 100. This is my I1. So I can write this as, from here, I1 minus, I'll just break this x power 49. You'll see why. Because I have x power 50 in the bracket. If I take this as a function t, it will become what? What's the differentiation of this? It will become x power 49. 50 will come in front. So I can write this as, I'll take x as it is, and I write this as x times of 1 minus x 50 power 100 times what? Times x power 49. You will see why. So I wanted to club these together. That's why. Here, these two are exponential function. This is simply algebraic function. Okay, not exponential function actually. This is in this form, and this is algebraic function. All right. So I'm gonna do this integration by parts. So let me assume this to be, okay, this is not I, forgive me. This is simply 1. This part is simply, the limit is 1, sir. Okay. Now have a look. I'm going to just solve this integration now using substitution by, and then I'm using by parts. Let's see what I can do. So over here, I can assume this to be, let's say, integration I. So I'm going to write this as, okay, this is a very important equation, equation 1. What is this equation 1? I2 equals to I1 minus this whole thing, I. I1 minus I. Okay, what is my I? Have a look. My I is, bacha, simply integration from 0 to 1 x 1 minus x power 50 to power 100 x power 49 and dx is there. Have a look. Yes. Now what I'm going to do next? I'll assume this part. Okay, I'll assume this part to be what? To be what? So for that, basically what I'm trying to do is, no, I'm trying to use the by parts. Okay, so remember this from by parts. I can write this as x as it is, x as it is. So this will not be integration sign. Okay, let me take the entire space over here because I'll require it. I'll take x as it is. Okay, next what I'm going to do, tell me. I'll do this for this integration. Integration of what? 1 minus x power, I'm taking this as 1 and this as 2. Okay, 1 minus x power 50, 100, x power 49 and dx, x power 49 and dx. Okay, from where to where? From 0 to 1. Okay, there will be what? Another a minus sign. Next what? Differentiation of this x. How much is that, bacha? Simply 1, simply 1. And again, I have to do the same integration for this thing. So 0 to 1, 0 to 1, 1 minus x power 50 to the power 100, okay, times x power 49 and dx. Okay, dx is there. Have a look. Dx is there. Again for the same thing, 0 to 1. Okay, now I think this space is not enough, so let me just remove this line and I'll solve it over here from here. So I can write the same thing over here like this. I'll write this I as, have a look, x will be what? So this part I'm doing right now. So I'm trying to actually do one thing. Forget about this whole integration right now. I'll try to solve this by substitution, this part. I'll solve this by substitution first. Let me just solve this part. Okay, this small integration in the parts. Okay, so if I do that, I'm going to get what? So let me just do one thing, substitute 1 minus x power 50, x power 50 as t. Please differentiate this. I'm going to get what? I get 1 is 0, I'll get what, minus 50 x power how much bacha, 49. How come sir? Because 50 minus 1, so 49 equals to what, dt by dx. So what is this thing? It's going to be x power 49 times dx is equals to what, minus dt by 50. Please have a look. This negative sign I'm taking on this side, so minus dt, okay, and then by 50, okay. Now I'll replace it in the integration. So if I do that, I'll get what, okay, just careful, this is a good question, has a lot of time, it will take some time because it's revising, in the same question revising multiple concepts, okay. By parts we are using and for exponential functions also, so multiple concepts is there. So what we're going to do, put it here, integration of 0 to 1, what is this bacha, please check. This is simply t power how much, t power 100, and this is what, minus dt by 50. How much is this going to be, please tell me. This is going to be, sir, simply t power 101, my sign will be there outside, okay, and this whole thing by 50 is there, forgive me, this whole thing by 50 is there, okay, by 50 into 101 in the limit what, 0 to 1. Please have a look. So I have done the integration for this green part, okay, this is the green part. Now I'll just put the same value over here and over here, over here and over here, you'll see. So if I do that, I'm going to write this integration I as x, okay, x times of, what is this integration, simply t, so with the minus sign, I'll write the minus sign. What is the t value, please check, 1 minus x power 50 t power 101, please have a look. I'm writing for this part, this whole thing, what is the t value, this part, and what is the power, not 100, not 100 sir, it's 101 sir, okay, 101. How come sir? Because t power 101 is there, t value is 1 minus x power 50, 101, how much is this number, 50, please check, 50, because 100 times of 50 will be what, 5000, and then 1 times of 50 will be 50, so 5050, okay. Now this is it from limit where to where, 0 to 1, 0 to 1. Now this is just for first part, okay, just for first part, okay. Now if you check here, I'm going to do what, for this part also I'm going to have to do, for this part I have to do as well. So I'm going to do what, again same thing I'll write for that part, minus sign, I have to do one integration, but for this integration I can write this thing as minus sign, because this part is same as this part. Now have a look, 1 minus x power 50 power 100 x power 49 dx, 1 minus x power 50 power 100 x power 49 dx. So I can write the same result. What result I got for this integration, I got this as this thing, so I write it as minus sign, t is what, 1 minus x power 50 to the power 101, t is what, t power 101 upon what, upon 50 times, so I can write it as 50 and how much is this, anything else is there, but sir this is not enough, I have to integrate it again sir, I have to integrate this again sir. Have a look, okay. Now please check, this minus sign, this will make positive over here, so I can write this I as simply this minus and this minus and XL club, so I get it as minus x, please check, this minus and this XL club, I get minus x, 1 minus x power 50 to the power 101, okay, 101 divided by 50, the whole thing with the limit 0 and 1. Now the last part, please have a look, I have the integration, right, I have the integration sign is visible, is very important, okay. There is a root over here, there is an integration over here, okay, again from where to where, from 0 to 1 only, okay. So integration of what, please check here, this minus and this minus will become what, plus, this minus over here, this will become what, plus, okay, so that is there, plus. Now 1 minus x power 50 power 101 upon 550, so forget about that right now, forget about the constant right now, 50, just look at this, 1 minus x power 50 power 101 dx, this is dx, okay, because dt is done now, dx, okay, 1 minus, so limit 0 to 1, 1 minus x power 50, what's the power now, power is what, 101, I can write this simply as, what bacha, tell me, I2 sir, simply as I2, 1 minus x power 50, 101, 150, I2, okay. So this This numerator, if you check here, the integration becomes I2. Now what is this now? I got this I as this value plus I2, this value plus I2. Put the limit over here, let's check. Put the limit over here. If I put 1, if I put upper limit, I'll get what? This will be 1, but this will be 1 minus 1 power 50. Please check. I'm putting upper limit. This will be 1. So this is 1, x is 1. 1 power 1 minus 1 power 50. 1 power 50 is how much? 1 only. 1 minus 1 will be 0, sir. What about this lower limit? Put 0 in place of x. Again 0, sir. This whole thing is 0. And what is this simply? I2 upon 50, 50. I hope this is visible. Okay. Please have a look. Please have a look at this part. I've got I as I2 upon 50, 50. Okay. All right. So use this equation from the 1. I2 equals to I1 minus I. I2 equals to I1 minus I. I2 equals to I1 minus I. Right? I2 equals to I1 minus I. What is my I value? Have a look. Simply I2 by 50, 50. I2 by 50, 50. Okay. Now let's read the question. It says find I1 by I2. I'm looking to find the ratio of I1 by I2. This is I1. If I divide this by I2, I'll get I1 by I2. So divide everything by I2. So I get what? I2 by I2 equals to I1 by I2 minus I2 by I2 times what, bacha? 50, 50. Cancel, 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 cancel. What is this? 1 equals to I1 by I2 equals to minus 1 by 50, 50. Please see from here. I can write this as 1 plus 1 upon 50, 50 equals to what? I1 by I2. So I get what? I1 by I2 equals to I1 by I2 equals to, take the LCM, I get 50, 50 plus 1 upon 50, 50. Not visible. Okay. Simply 50, 50. Right? What is my answer, bacha? Simply 5051 upon 5050. Have a look. I hope this is visible. Okay. Simple. All right. Answer is simple, but question was difficult. It was a challenging question. Okay. I'll walk you through it again. I took this I2 first. Okay. Then I broke this, the power 101 as 1 times of 100. I wrote this multiplication with 1 over here, and this with the x power 50. I broke x power 50 as x power 49 and x. Took this as this part as my I. Applied by parts for it. I hope this is visible. By parts over here. Then I got another integration. I took the substitution for that to get the answer as minus t power 101 upon 50 into 50. So 50, 50 actually. What is t? T is my 1 power x power 50. Okay. I have shown you the differentiation of the substitution over here. Got the result and got my I2. Got my I value as I2 upon 50, 50. Okay. Now put it in this condition. I2 minus I1. This is from equation 1. From equation number 1. And divided everything by I2 to get my answer as 50, 51 by 50, 50. I hope this is visible. Moving on to the question number 7. All right. Okay. So actually there's one more doubt in this question. Some places they've given answer as minus 1. Some places the answer is minus 1 by 2 also. So please check your answer and let me know. So comment your answer. I'll verify. I will verify this. Okay, chaliye kar lete hain. Okay, let's do this. So what can I take, bacha? First of all, the root is there. You're giving me trouble. Let's do one thing, rationalize this root first. So I have to find this in this form, and then do what? Find the value of a plus b plus c. A plus b plus c. Okay, let's see what can I do about this. First let's take this rationalization over here. Root is there, it's bothering me. Let's check. So I'll take I equals to integration of x cube. Okay, rationalize this in the root only. 1 plus x square upon 1 minus x square times of 1 plus x square upon 1 plus x square. How much I get? I get this as root of x cube. How much is this, bacha? Tell me. This is going to be simply 1 plus x square the whole square upon, how much is this? 1 minus x square. 1 minus, not x square, x power 4. X power 4. How much is this? 1 minus x power 4. Please have a look. Okay. This will become x cube This is what simply 1 plus x square, and how much is this? Please have a look. It will become root of, what is this? Root of 1 minus x power 4. Okay, dx is there. Now comes the substitution. So if I take let's say x square equals to, how much is it? Sine theta. If I take sine theta, how much this will be? Okay, how much will this be? Please check. So I'll get this as, differentiate this first. So 2x dx, okay, equals to what? Cos theta d theta. Yes. So what I have this x dx equals to 1 by 2 cos theta d theta. Am I right? 2x dx equals to cos theta d theta. So x dx equals to 1 by 2 cos theta d theta. I'll use it over here. So as x cube, I write it as x square times of x. So I get what? Please check. I get sine theta, because what is it? X square will become sine theta from here. Okay, and then I'll get what in the bracket? 1 plus x square is how much again? Sine theta. And what is dx? I'll write dx over here. I don't have enough space. Okay, I write this as 1 minus sine square theta. I hope this is visible. Okay, so let me write this step over here. I can write this integration I as, with the d theta I'll write. So what is this going to be, bacha? Tell me. Okay, achha, one more thing. I have a x left here. Okay, not visible. Not visible, sir. So let me just rewrite this part again. So check here. This was x cube, no? I have taken x square only, sine theta. So I will have to take one more x. So my x dx is left over here. Now I'll write the value of x dx from here. X dx from here. Please check. So I'll get what? Sine theta will be like this. So I'll get what? Sine into sine will be sine into 1 will be sine theta plus sine square theta. What about the root? 1 minus sine square is simply what? Cos square. 1 minus sine square. How is the sine square? Because x square is sine theta. So sine x power 4. X square is sine theta means x power 4 is sine square theta. So 1 minus sine square theta is simply what? Cos square theta. In the root will become what? Cos theta. It will become what? Cos theta. How come? How about x dx? X dx is what, sir? 1 by 2 cos theta and d theta. Have a look. X dx is what? 1 by 2 cos theta d theta. So cancel this cos theta, cos theta. Now what is my integration looking like? 1 by 2 is a constant. I can take it outside. Okay, 1 by 2 is constant. I can take it outside. I get it as sine square theta plus sine square theta d theta. Sine theta plus sine square theta d theta. Okay, do one thing over here. Integration of sine theta, separate it and write this as integration of, again I'll take 1 by 2 over here also. Let me write it anyway. I'll write 1 by 2 over here also. Okay, because 1 by 2 multiply to entire integration, no? So 1 by 2 over here also. Integration of sine square theta d theta again, d theta again. I get what? 1 by 2. How much is this? Minus cos theta. Please check. Plus 1 by 2 integration of what? 1 minus how much is this, bacha? Cos 2 theta. Cos 2 theta. Yes or no? Yes, please have a look. Okay, so now if I integrate this, what I'm going to get? Minus 1 by 2 cos theta, and how much is this? Plus I integrate this 1 by 2 times of d theta minus 1 by 2 times of, how much is this? Cos 2 theta d theta. Yes or no? Integrate, bacha. How much is this? Minus 1 by 2 simply cos theta. How much is this? Simply 1 by 2. Okay, 1 by 2. All right, 1 minus sine square theta by 2. Okay, one more 2 will come over here. One more 2, because the formula is what? The formula is cos 2 theta equals to what? 1 minus 2 sine square theta, no? So if I'm writing for only sine square theta, what I'm going to get? Please check. I'll get it as 1 minus cos 2 theta equals to what? 2 sine square theta. So since there is no 2 sine square theta over here, I have to what? Divide over this. So I get this as sine square theta equals to 1 minus cos 2 theta upon 2. So this 2 will come. So this will be simply what? 4 over here. I missed a 2, forgive me. This will be simply what, bacha? 4 over here, and 4 over here. Okay, so I get what this as plus 4. How much is this? Simply theta. Okay, and how much is this? Minus 1 by 4. Now if you check here, check this integration, whatever I get. Okay, now please check. I'm looking to for the coefficient of a, b and c. A, B and c. Okay, so if you add them, okay, if you just simplify, put the value of theta from here. From where you gonna put? From here you can put, bacha. From here you can put. You'll get what? Sine inverse of x square. Okay, sine inverse of x square, you can write it like this. So please check. If you do that, you'll get what? So if you put it in that term, you'll have what? The coefficients, if you check. How much is this? My a plus b plus c, the coefficient will be what? Minus 1 by 2 plus 1 by 4 and minus 1 by 4. How much is that? Please check. Goes out. Okay, simply answer is minus 1 by 2. Okay, please have a look. Answer is B. Now there is, I told you there is a possibility that, 1 second. Okay, there has been cases where this answer is coming as, okay, D also. Okay, both of the options are there. Okay, please check. I will verify. Comment in the comment section what you are getting answer. Tell me your approach. I'll cross verify it and give you the final solution for this. Okay, we'll discuss this question again if you want me to, but for question number 7, comment below. Both options are coming. Okay, so please check. All right, moving on. Have a look over here. I hope this is visible. Yes, so this is not done, but you have to complete this question. Last step, you have to complete this. Since I don't need it right now because I had to just a plus b plus c, that's why I've taken a plus b plus c as the sum of the coefficients. Minus 1 by 2, 1 by 4 and minus 1 by 4. Answer is minus 1 by 2. Moving on. Question number 8. Question number 8. dx upon sine 2x tan power 9x. Okay. How will I solve this? Please have a look. So I can write this this one like this. So let me take it like this. I equals to integration of dx upon sine 2x tan power 9x is there, right, bacha? Take tan in the numerator. What I'm going to get? I'm going to get this as dx as cot 9x. Okay, and what is sine 2x? 2 sine x cos x dx. Am I right? Now bring this. One thing you can do, bring one of the cos over here and bring this write this as one of the cos by sine. We'll check like this. I'm saying that 1 by 2 is a constant outside, so write this as cot power 8 and write this as cos x by what? By sine x. Multiply with the sine x with that we have, and over you write it as cos x. Check what you're gonna get. Cancel cos and cos. Cancel cos and cos. Okay. Now what I have over here, please have a look. I get this as integration 1 by 2 integral of what? Cot power 8. Cot power 8x. Okay. 8x. And what is this? Sin x into sin x is what? Upon sin square x. Sin square x. What is this, bacha? With dx. I can rewrite this. My integration I equals to 1 by 2. Please have a look. Cot 8x multiplied with what? 1 by sin is how much? Cosec square x. Cosec square x. Okay. Cosec square x dx. Okay. Right. So I'm writing this over here again. My I is equals to integration of, what is this? Cot 8x and cosec square x dx. Please have a look. Okay. Please have a look. So if I do like this, what I'm going to get, bacha? Do substitution. Substitution will be what? Cot x equals to, if I take it as t, what is the differentiation of this? Minus cosec square x dx equals to what, bacha? Simply dt. Take this dx value from here. So I get plus I'll take cosec square x dx equals to what? Minus dt. Put it here for this value. I get what? T power 8 minus dt. Bring minus sign outside. So 1 by 2 is there. 1 by 2 is there. So everywhere 1 by 2 is there. So I'm going to bring this minus 1 by 2 as it is. What is this going to be? T power 8 dt. What is the answer for that? Minus 1 by 2. Please have a look. It will become T power 9 by 9 plus C. How much is that? Minus 1 by 18. What is T? Cot. So cot power 9 x plus C. My final answer. Please have a look. Okay. Option number D is correct. Yes, have a look. Visible. Okay. Question number 9. Integral of 2x cube minus 1 upon x power 4 plus x dx is equals to what? C is the constant of integration. Alright, let's see. How can we solve it? Right now, we have to make some modifications to get into the substitution form. If I divide everything by x square, let me try this. Okay. So what I'm trying to say here is, take this I equals to like this, 2x cube minus 1 upon x power 4 plus x dx. Now divide everything by x square. So I get what? 2x cube minus 1 whole thing divided by what, bacha? X square upon x power 4 plus x divided by again x square. What I'm gonna get, please check. I'll get my I value as integration from where to where. There's no limit over here, sorry. So you're gonna get 2x minus 1 by x square, correct? What about this? You're gonna get x square plus 1 by x. Alright, this is very simple, right? Please check. I'll write this over here again. So my I equals to what? Integration of 2x minus 1 by x square upon x square plus 1 by x dx is there, right? Yes. Now do one thing. Take t equals to x square plus 1 by x. X square plus 1 by x. What will this be? Differentiate dt equals to 2x minus 1 by x square, no? Correct? Because x power minus 1 will be there. Over here 1 by x is what? X power minus 1. The sign will become negative, and again minus 1 will become minus 2, comes denominator will be simply what? 2. I can write this as I equals to what? I hope there is no doubt over here. Okay, there is no doubt about how to differentiate 1 by x. So this is going to be 2x times of this whole thing will become what? Simply dt, and this is my t, bacha. What is that? Log of t plus c. How much is that? Log of, what is t, bacha? Tell me. X square plus 1 by x plus c. How much is that? So log of x cube plus 1 by x plus c. An option like this is log, okay? Okay. Right? Option number C, have a look. Log of x cube plus 1 upon x by c plus c. Yes. Okay. Correct, right? Have a look. Visible. Moving on to the next question, which is the last question of the day. How much is that? This is a definite integral. This we know. How much is going to be? Take x equals to tan theta, sir. Very, very simple. X equal to tan theta, sir. Then if you do that, what are you gonna get? Tell me. Differentiate it over here. I get x equals to tan theta means d theta dx equals to what? Sec square theta d theta. Am I right? Okay. Now this is simply going to be what? 2 tan theta upon 1 plus tan square theta. And how much is that? Simply sine 2 theta. Write it over here. 0 to root 3. How much is that? Actually, limit I have to change again. Forgive me. I have to change the limit, no? Since the variables is changed in substitution, I have to change the limit also. Check the change of limit. When x was what? 0. What is the substitution? I have this as, x is 0. What is the condition? Tan theta, right? So what is my theta? Tan inverse of x. How much is that? Tan inverse of 0. How much is that? 0. So when x is 0, theta is 0. So 0 over here. When x is root 3, I get what? Theta equals to tan inverse of root 3. How much is that, bacha? Tell me. Pi by 3. How much is that? Pi by 3. So write it here. Pi by 3. Pi by 3. Visible? Okay, now I can write this as sine inverse of simply what? Sine 2 theta, and what does that tell me? Dx equals to what? Dx equals to sec square theta d theta. So sec square theta d theta. How much is that, bacha? Please tell me. I equals to 2 theta sec square theta d theta. Yes or no? From where to where? 0 to pi by 3. Pi by 3. Take 2 outside, constant. Have a look. 1 second. Take 2 outside. So I equals to what? 2 outside. From 0 to pi by 3. Okay. How much is that? Theta sec square theta d theta. Yes or no? Sec square theta d theta. So have a look. 2 is outside, 0 to pi by 3 is there. Okay. I have to use what, bacha? I have to use by parts, sir. Okay, this is my 1, this is my 2. I let, okay. Algebra has preference over the trigonometric function. So write like this. Theta will become what as it is. Sec square integration will be what, bacha? Simply tan theta. Simply tan theta. Okay. What about this? I'll have a minus sign. Over here I'll have what? Integration for what? This differentiation will be 1. For again I'll get what? Tan theta. Okay. How much is this going to be? 0 to, whole thing will be under the same limit, no? 0 to pi by 3. I'll do it later. Okay. 2 times of what? Theta tan theta. And how much is this? Minus and minus will become what? Plus, because this is going to be log cos theta. 0 to pi by 3. Have a look. Tan theta integration is what? Log minus cos theta, right? So minus and minus will become plus. For this I'll have a minus, will become plus, no problem. 2 times of what is the value? Pi by 3 you put here. So pi by 3, how much, bacha? Tan of pi by 3 will be what, bacha? Simply root 3. Okay. Now what about this? Over here also you're going to get cos pi by 3 is what? Root 3. So you're going to get what? Log of, sorry, cos of pi by 3, right? So it will become what? Sorry, forgive me. It will become what? It will become what? Cos pi by 3 is what? 1 by 2. It will become 1 by 2 over here. Okay. And for 0, tan 0 is 0. So this whole thing is 0. What about this part? Cos 0 is what? 1. And log 1 is what? Simply 0 again. What is my answer? 2 times of pi by root 3. Okay. Pi by root 3. And this will become what? Please have a look. I can take this as, so I'll multiply this. So I get what? Plus 2 times of log 1 by 2. Okay. Now this, I'm going to take this as 2 power minus 1. I get this as 2 pi by root 3. Okay. By root 3. I hope this is visible. 2 pi by root 3. I'll rewrite this again. Okay. This will become what, bacha? Tell me. I can write this as plus 2 log power 2 minus 1. Bring this minus 1 here and bring this 2 here. Okay. So I can write this as final answer, just for the final answer sake. 2 pi by 3. 2 pi by root 3, not 3, root 3. This will become what? I'm taking this minus outside. So minus 2 log of 2. Bring this 2 inside. Okay. It will become what? Same thing will be there, but it will become 2 pi by 3, sorry, root 3 minus log of 4. So what I'm saying is, first I took minus sign outside. This is minus 1. I took minus 1 outside for the log property, and then I took 2 inside. This 2 inside will become 2 power 2, so 4. My answer is what? 2 pi by root 3 minus log 4. Option number D. So this concludes your revision of the first for integration. Okay, this can have a look here first. So this concludes your revision of what, bacha? Integration. I'll come up with more questions to revise your integration with you. Okay, there I've given a couple of questions. I've given you to verify one of the answers. Please cross check from your side, put some effort. Okay, this will give me more energy to come up and give you more and more sessions. All right, so keep working hard, and this is for the revision of the today's session. And keep positivity around you, keep working hard. I'll see you in the next session. That's it for today's session. Take care. Bye bye.